Assalamualaikum warahmatullahi wabarakatuh. I am Siti Hajarli. For assignment regression analysis, our group have chosen a topic that is logistic regression modeling, comparing the effect of factors influencing graduate employment in Malaysia. These are my group members. I'm Siti Hajarli. The rest are Nurul Nabiha, Nur Shakira, Fadilatul Ahya, and Aishwarya. Little bit of introduction about our topic. Employability is the capability to secure a job and preparedness to perform well upon entering the workforce. Little bit of literature review. Based on model built in previous study, profiles such as gender, academic discipline, and cumulative grade point average, CGPA, have repeatedly found to be the factor affecting graduate employability. The data set that we are analyzing is about graduate employment in Malaysia. The scope of our interest is science, technology, engineering, and mathematics, or as known as STEM. This dataset consists of those variables that are gender, family income, English, CGPA, discipline, and employment. Employment is chosen as the dichotomous dependent variable because it has two levels, that is employed and unemployed. For background of data, this dataset is collected from Survey SKPG1, which is conducted by Ministry of Higher Education. It is a compulsory survey to be filled by newly graduates within 6 months after convocation. And this dataset includes all universities and TVET institutions in Malaysia. For our analysis, we are focusing on the 6,854 graduates from STEM disciplines. Logistic regression model is a statistical model that in its basic form uses a logistic function to model a binary dependent variable. It is used to describe data and to explain the relationship between one dependent binary variable, that is the employment, because we have employed and unemployed levels, and one or more nominal, ordinal, interval, or ratio level independent variables. It can be of categorical, continuous, or both as independent variables. So the model is given by logic pi, that is beta naught plus beta 1 xi1 until beta p xip. Beta naught is the intercept, while beta 1 until beta p are the estimates or the coefficients for each of the predictors in the model. So p is the number of predictors in the model. Next, we see some interesting results of the odds ratio of factors influencing graduate employment. These odds ratio are obtained from the exponent of the coefficients in the model. So we can see that gender male has the odds ratio of 1.3598505, which means that male has about 35% more chance than female to be employed from this dataset analysis. We can see that for family income, we can see that 23% or almost 24% of odds ratio is written for family income M40. This means that graduates with background family income M40 has 23% more chance than graduates coming from family with income in M40 category. Because family income B40 does not appear here because it has been chosen as the baseline for this analysis. For English, we can see that English satisfactory has the highest odds ratio. So this means that 36% more chance than English excellent. This means that graduates with satisfactory English has 36% more chance than graduates with excellent English, which are an interesting result. For CGPA, the only continuous independent variable in our analysis, we can see that it gives our analysis a result of odds ratio 1.2275. This means that for a unit increase in CGPA, there's 22 or 23% more chance for graduates to be employed. This shows that academic achievement is still very important, and it is still significant to be a criteria for employment, where employers still seek for this quality that is the academic achievement. So for discipline, there are 4 disciplines in this dataset, that is ICT, Technique, Science, and also Arts and Social Science. Arts and Social Science doesn't appear here because it has been chosen as the baseline for this analysis for the sake of comparing the odds ratio. So we can see that 0.594 for discipline ICT is the highest among these 3. This shows that graduates from ICT discipline has the odds of 0.59, has a reduce of 0.59 chance, that is the factor to be employed as compared to the graduates from the discipline of arts and social sciences. For the next part, I'll pass to Shakira to continue. Thank you.
Wabarakatuh. My name is Nur Shakira binti Muhammad Fauzi and my Matric ID is 17134161. I'm going to present regarding variable selection. Variable selection is intended to select the best subset of predictors. There are a few criteria that can be used, and we are using Akaiki Information Criterion AIC in this regression analysis. So the procedure is known as stepwise procedures, and it can be done in three ways, which are backward elimination, forward selection, and stepwise regression. In backward elimination, it will start to examine the model with all the variables included. First, if the AIC value of the model is higher than the AIC value of one variable being removed, then the removal of variable that gives the lowest AIC value will be done. This process is repeated until the AIC value of the model gets to the lowest value with remaining variables. In forward selection, it will start to examine the model with no variables included first. If the AIC value of the model is higher than the AIC value of any one variable be added, then it will proceed to add the variable that gives the lowest AIC value. This process is repeated until the AIC value of the model gets to the lowest with added variables. This is the output for backward elimination, and we got the result for AIC value, the lowest, which is 8141.42, with all the predictors included. Same goes with forward selection. The final result for forward selection with AIC 8141.42 with all predictors included. Stepwise regression is the combination of forward selection and backward elimination. This process is still the same, however, after an addition of a variable to the model, the added variable can be eliminated from the model if it results in higher AIC value in the next step. This process is repeated back and forth until the lowest AIC value is obtained from the model. As you can see here, from the start, our AIC value for the model with no predictor is 8368.6. After we added variables into the model, we'll get the final model to it with the AIC of 8141.42 with all the predictors included, which are discipline, English, gender, CGP, and family income. So based on the procedures above, all of them reach to the same final model that includes discipline, gender, English, family income, and CGP as predictors with the lowest AIC value, which is 8141.42. From this result, we built a logistic regression model with all the predictors mentioned above, and our dependent variable is employability. So that's all from me. Thank you.
Hi everyone, I'm Nabiha, and now it's my turn to present about hypothesis testing. In logistic regression model, hypothesis testing is used to determine the significance of a specific variable and also to determine the overall effect of selected variables. And we can do this by testing the coefficient associated to the variables using hypothesis testing. And here, Wald test is used. So in our example, we have 5 independent variables, which are gender, English, CGPA, family income, and also discipline. So let's take a look if family income is a significant variable in our logistic regression model or not. So we let H null be beta I equals to 0 and H alternative be beta I is not equals to 0, where beta I is the coefficient of predictor family income. So this is the codes to test the coefficient of family income, and the test used F distribution with 2 and 6,843 degrees of freedom, and the test yielded F value 3.11 and P value of 0.044635. So if we let our significance level to be 0.05, then the P value obtained is smaller than the values of alpha. So we reject H null. This is equivalent to say that we reject the hypothesis that say or claim the family income variable is not significant, which means family income variable is actually significant. But if we want to be more precise and let the significance level to be 0.01, then the p-value obtained here is larger than 0.01. So we accept H null, and it means the variable family income is not significant in our logistic regression model. So the table shown here is the result for all variables tested using Wald test for both significance level equals to 0.05 and also 0.01. Now let us see the overall effect of all 5 independent variables in our logistic regression model. So Wald test is also used here, and we let H null be beta 1 equals to beta 2 equals to all variables until beta 5 equals to 0, and H alternative be beta I equals to not equals to 0 for at least one I, which the I is 1 until 5. So this is the codes, and the Wald test use chi-squared distribution, and the value is 209.8 with degrees of freedom 10. So the p-value obtained is 0. So in this case, whether we let our significance level be 0.05 or 0.01, both values are still larger than the p-value obtained. So it is equivalent to say that the p-value 0.0 is smaller than both significance levels. So we reject H null, and this means all independent variables are statistically significant.
Greetings, Dr. Rosita. I'm Aishwarya, and I will further explain on confidence interval. In logistic regression, confidence intervals are a range of values that are likely to contain the values of the odds ratio for every predictor variables. It also measures the degree of uncertainty associated with the odds ratios. The wider the interval, the greater the uncertainty associated with the estimates or odds ratios, and vice versa. The confidence interval for the estimates is denoted as beta I and is given by beta I plus minus z1 minus alpha over 2 as beta I hat. While the confidence interval for the odds ratios of the predictor is obtained by exponentiating the confidence interval for the estimate. The exponent confidence interval command is used to obtain the 95% confidence interval for the odds ratio for every predictor variable as shown on the screen. A table is then constructed which consists of a level of predictor, estimates, odds ratio, the p-value, and the 95% confidence interval. From these results, some interesting interpretations are made. First, the 95% confidence interval for gender male ranges approximately from 1.22 to 1.52. It traps the odds ratio of 1.3598505 in the confidence interval. This means that in 95% of the occasions, male graduates are 22% to 52% more likely to be employed than female graduates. This indicates high degree of gender inequalities in employment of graduates in Malaysia. And we can say that female graduates are having tougher time to secure a job upon graduation. Next, the 95% confidence interval for family income M40 spans approximately from 1.047 to 1.47. The confidence interval contains the odds ratio of 1.2398674, as shown in the table. It can be concluded that in 95% of the occasions, graduates who are M40 category is 4% to 47% more likely to be employed than those in B40 category. This huge range shows that there are wider possibilities to find the true values of the odds ratios. That is all from me. Thank you.
Hello, I'm Fadila and I will explain on the model adequacy. So in our analysis, model adequacy is evaluated based on the coefficient matrix and receiving operating characteristic curve. But first, I will explain on the coefficient matrix first. So the coefficient matrix is used to evaluate the model performance by visualizing the actual and predicted value. And it also provides the information needed to calculate sensitivity and specificity for the model at zero point 0.5 thresholds. So here are the R codes that we use to obtain the coefficient matrix in the form of histogram. So figure here shows the histogram that we obtain from R. So based on the histogram, it shows that the probability of getting true positive and true negative accumulate at 0.6 to 0.75, as we can see here. The probability shows that it indicates the fairly good predictive power since it surpassed the threshold level, which is 0.5. This diagram will be translated to ROC curve that I will explain after this for a better interpretation. So now we move on to the receiving operating characteristic. So in our analysis, the receiving operating characteristic is used to evaluate the model adequacy, and the model adequacy is evaluated based on the area under the curve AUC of the receiving operating characteristic curve ROC. The ROC curve is constructed by plotting the true positive rate against the false positive rate. The ROC curve of probability and AUC is the degree or measure of the predictive ability. AUC usually range from 0.5 to 1, and the higher the AUC, that is greater than 0.5, the better the model predictive ability. So below are the R codes that we use to obtain the ROC curve to evaluate the model adequacy. So here are the output that we obtain from the R. So based on the output, we found out that the area under the curve is 0.6078, which means 60% of the time the logistic regression model can distinguish the negative and positive outcomes. Based on my readings, a very poor model has AUC in the range of 0.5 to 0, and the curve usually below the straight line or on the straight line. But as we can see here from our output, our curve shape above the line and the AUC is greater than 0.5, which indicates that the logistic regression model has a moderate to good predictive accuracy. So that's all from us. Thank you for listening.